Hey everyone! Today I'm diving into the mind-bending world of thermodynamics. And trust me, this stuff explains why you can't build a machine that runs forever, no matter how clever you are. Zeroth law. If two systems are each in thermal equilibrium with a third, they are in thermal equilibrium with each other. Let's start at the very foundation with something called the zeroth law of thermodynamics. Sounds weird, right? But this law is actually what lets us talk about temperature in the first place. It says if two systems are each in thermal equilibrium with a third, then they're in equilibrium with each other. In plain English, if my coffee and my hand feel the same temperature as my thermometer, then the coffee, my hand, and the thermometer all share the same temperature, even if they're not touching each other directly. That's why thermometers work. Super simple, but super important. First law: energy cannot be created or destroyed, only transformed from one form to another. Now, the first law of thermodynamics. This is the famous law of conservation of energy. Energy cannot be created or destroyed, only transformed. For a closed system, the change in internal energy equals the heat added minus the work done by the system. Mathematically, that's du equals Q minus W. So if you heat up a gas in a piston, some of that energy goes into raising the temperature, and some gets used to push up the piston. Here's the kicker. This law is why perpetual motion machines, the kind that make more energy than they use, are just impossible. You can't get something for nothing. Second law. The total entropy of an isolated system can never decrease. It always increases or remains constant. On to the second law of thermodynamics. This one introduces a totally new idea: entropy, or the measure of disorder in a system. Here's the rule. The total entropy of an isolated system can never decrease. In other words, things get messier over time, not neater. Heat flows naturally from hot to cold, never the reverse. That's why your ice cream melts on a summer day. It never spontaneously gets colder. And if you've ever tried to unscramble an egg, you know some things just can't go back to their original state. The second law also means every engine loses some energy to heat, so no machine can ever be 100% efficient. Third law. As a system approaches absolute zero, the entropy of a perfect crystal approaches zero. Finally, the third law of thermodynamics. As you cool something closer and closer to absolute zero, 0 Kelvin, the entropy or disorder of a perfect crystal approaches zero. Think of it as perfect order. But here's the catch. You can never actually reach absolute zero, no matter how hard you try or how many steps you take. Scientists have gotten really close, but absolute zero remains forever out of reach. So, to sum it all up, thermodynamics sets the ultimate rules for energy, heat, and temperature. It tells us why perpetual motion is impossible, why time moves forward, and why your hot coffee always cools down. And honestly, that's what makes the universe so fascinating. Thanks for watching, and keep asking questions.